Hello everyone. In this video we're going to be solving a polynomial system of equations. We have three equations and three variables. We're going to be solving for x, y, and z. Let's go ahead and get started. So the first thing I'm going to do is subtract these two equations. So if I subtract this way, the smaller one from the larger one, I get the following: x plus z plus xyz minus x minus y minus xyz equals 3. xyz cancels out and x cancels out, and I end up with z minus y equals 3. Now I'm going to use this to write z in terms of y. So I can write z equals y plus 3. Great. So if you call this equation number 1, if this is 2 and this is 3, the first thing we did was subtract 2 minus 1. Okay? Subtract 2 minus 1. And the next thing we're going to do is subtract 3 minus 2. Okay. Now the third equation is y plus z plus xyz. If I subtract the second, negating everything, I get 17 minus 16, which is equal to 1. Great. Similarly, xyz is going to cancel out, and z is going to cancel out. And I end up with y minus x equals 1. Now from here, notice that when I did the first operation, subtraction of 2 and 1, I wrote z in terms of y. I'd like to keep it consistent and write the x in terms of y as well, so you can write x equals y minus 1. Okay, so now we're able to express x and z in terms of y. Let's go ahead and plug everything into the first equation. Now let's remember what the first equation was. Our first equation was x plus y plus xyz equals 13. Great. Now let's go ahead and substitute z and x into this equation. And x is gonna stay the y is gonna stay the same, so x will be replaced with y minus 1, y will be y, and x will be y minus 1, and y will stay the same. So let's just write it like this: y times y minus 1 times y plus 3, and the whole thing is equal to 13. Okay, let's go ahead and simplify this. Y plus y is 2y minus 1. And if you distribute, these two is going to give you y squared plus 2y minus 3. And then you got to multiply that by y and add. So it's going to be y cubed plus 2y squared minus 3y. And the whole thing is equal to 13. Let's go ahead and, combine like terms. This is going to give me y cubed plus 2y squared. 2y plus 3y is going to be, actually not plus. 2y minus 3y is going to be negative y. And our constant is going to be, if you bring the 13 over to the left, it's going to be negative 1 minus 13, which is minus 14. And the whole thing is equal to 0. Great. So this is a cubic equation, and obviously you may want to go with the Cardano's formula or the cubic formula, but there's an easier way to do it. Using the rational root theorem, if there are any rational solutions, which we have to look for first, right? Obviously, then they have to be divisors of 14. Plus minus, of course. So when we say plus minus, it could be a positive or negative. So plus minus 1 is a good candidate, plus minus 2 is a good candidate, plus minus 7 is a good candidate, and plus minus 14 is a good candidate. There's 8 candidates that you can kind of test out with either long division or, just by direct substitution. And after, doing all these things, you're going to find out that y equals 2 is a solution. And we can easily show that because it's 8 plus 8 minus 2 minus 14, and that is equal to 0. Great. So y equals 2 is a solution. And by using our usual trick, now you can go ahead and divide, y minus 2 into this. So you can just divide by long division and find the other quadratic polynomial. Or you can use the trick that we've been using in other videos. So that trick involves taking this cubic expression and arranging the terms so that they're always divisible in pairs by y minus 2. So we can do the following: y cubed minus 2y squared. Notice that this is divisible by y minus 2 because I can take out a y squared, and then I'll be getting y minus 2. But that means I have to add 4y squared to get the 2y squared back, and then I have to subtract 8y again to make it divisible by y minus 2. In other words, the second number must be the second coefficient must be 2 times the first coefficient, and the sign must be minus. And then I do need negative y or negative 1y, so I have to add positive 7y, and then of course the last term is just going to stay like that. So now we can factor this by grouping, and here we take out 4y. This is just a cooler way to do it. It's pretty much, you know, long division or synthetic, but it's just nicer. Okay, now y minus 2 is obviously a solution because we know that y equals 2 is a root. So we can take out y minus 2, and that will bring us the quadratic. All right, great. So now we already know that y equals 2 is a valid solution, and we're going to use that obviously to find x and z. But let's just go ahead and find the y values, and then from there we're just going to find everything. Okay, the second equation, unfortunately, or maybe fortunately, I don't know, depends on how you look at it, does not have real solutions. If you set this equal to 0, then you'll get complex solutions. And there's a couple of ways to do it. You can use the quadratic formula or complete the square. So you can kind of like isolate the negative 7 and then add half of 4 squared, which is 4 to both sides, to make the left-hand side a perfect square. And this gives you y plus 2 quantity squared equals negative 3. As you know, there's no real number whose square equals negative 3, but there are complex numbers whose square equals negative 3. And what are those numbers? Let's take a look at them. So y plus 2 must be then plus minus square root of 3i. And this gives us the two y values. Y equals negative 2 plus root 3i, and y equals negative 2 minus root 3i. And we also know that y equals 2, which is our only real solution. Great. So let's go ahead and use the formulas to find x and z. Remember, we were able to express x and z in terms of y. Okay, great. So we're going to use those now. Let's go ahead and substitute. So we had z equals y plus 3. So z is going to be 3 more than y, which means that z here is going to be this number plus 3, which is 1 plus root 3i. Here z is going to be 1 minus root 3i. And when you add 2 plus 3, z is going to be 5. And then let's go ahead and find the x value. The x value, as you'll remember, was y minus 1. And so we're just going to take, we're going to subtract 1 from each of the y values. So here x is going to be negative 3 plus root 3i. And then here it's going to be negative 3 minus root 3i. Notice that these are kind of like conjugates, right? Those x values. And here x is going to be 1. Okay? So we are getting basically 3 ordered triples as our solution. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.